Alright, today we are going to be talking about logarithmic functions and their graphs. Alright, so a couple of things. First of all, the functions, okay? We're going to be talking about the logarithmic function and the natural log function, okay? And they both look kind of like boomerangs, okay? The interesting thing is your y equals log x, okay? It passes through this one. I don't know where it is, about right there. Okay, but it passes through there and it makes this kind of curve. Your natural log is just pretty much kind of steeper. Notice that they both pass through 0, 1. The mothers do. Okay, so what you need to know too is their inverses. Alright, here's your natural log function. The inverse of the natural log function is e to the x. Those are inverses, and you can tell because see how mother splits them in half. The logarithmic function, the inverse for the logarithmic function is 10 to the x, and they're inverses. Okay? So, first thing we're going to learn is how to change between logarithmic and exponential form. You know exponential form. This you've worked with. This you haven't. Okay? And what it says is if x is greater than 0, and b is greater than 0 but not equal to 1, then y equals log b of x if and only if b to the y equals x. Here's your story, okay? If I have a log of some base b of x and I claim that it equals y. Alright, if you've ever been out in Florida, anywhere, and you pick up a log, what the heck are you going to find underneath it? A whole bunch of bugs, right? Eating the bugs and worms. So, when the log, what you do is to switch to exponential form is you roll the log over. When the log rolls over, the bug moves over. Okay? Because when the log rolls away, all the bugs go, ah, it's bright, and the bug runs away. Okay? And what he does is he runs to the other side and becomes the base, and this becomes the exponent. So x drops. And that will equal my b, my bug, my base to the y. And that's how you translate back and forth. Okay? So, it says write each in exponential form. So I have log base 3 of 9 equals 2. Well, again, what you do to rewrite this in logarithmic form is you roll the log, which squishes the... When the log rolls over, the bug moves over, okay? So what happens is 9 drops, and this becomes 3 squared. And you can tell that that's true. 9 does equal 3 squared, okay? On the second one, when the log rolls over, the bug moves over. So I have 1 over 100 equals 10 to the negative second, which is true. Because if you rewrote this side, 10 to the negative second equals 1 over 10 squared, which equals 1 over 100. It's true. Okay, when the log rolls over, the bug moves over, so I have 1/9 equals 3 to the negative second, which is true, because 3 to the negative second would be 1 over 3 squared, which would be 1 over 9. When the log rolls over, the bug moves over, so I have 8 equals 2 cubed, which is true. 2 cubed is 8. Okay? Now, to go backwards, you're starting here and you want to go back to here. Well, remember, this is the bug. Whoever's got the exponent has got that's the bug. He's got to move back to the other side and crawl under his log. So if he moves back to the other side, the 3 is going to drop down, the log comes back, the bug goes back under, and 125 stays. Okay? So on this one, there's the bug. He's going to move back over, so 1/3 drops, the bug crawls back under the log, and there you go. Okay, so same thing here. There's my bug. He crawls back over under his log, so 1/2. 81 goes back under the log with 9. Okay, the base moves back under his log, so 4 equals log base 3 of 81. Okay, that's going backwards. Alright, now why are we learning that? Well, because remember what I told you before, okay? We're going to use logarithms when we're solving to try and get like x out of the air. But before we can do that, again, they're going to give you start slow and easy, okay? So we're going to solve this by changing it to exponential form. So the log rolls over, the bug moves over, and I have x equals 8 squared. X is alone. Evaluate this and we're done. X equals 64. Now what about this? Where's the bug? Who's the bug? I don't see a bug. If they don't write a bug, it's your bug is 10. Because logarithms work on base 10. Well, some of them. Alright, so the log rolls over, the 10 moves over, and that gives me x equals 10 to the negative second. So if I evaluate this, I'll be done. Well, that's going to be 1 over 10 to the second. And that's going to be 1 over 100. Okay? The log rolls over, the bug moves over. I get x equals 9 to the 1/2, which is the square root of 9, which is 3. Okay? Alright, so you do this one. Come back when you're ready. Hit pause. And hopefully you got 4. I mean, I wouldn't have written it like that, but the bug moves over, so x equals 5 to the negative third. And you can't leave a negative exponent, so x equals 1 over 5 cubed. And I would have actually multiplied that out and got 125, but they left it like this. Alright, so hit pause, come back when you're ready. And hopefully you got 1 or 4. Okay, the log rolls over, the bug moves over, so I have x equals 4 to the 1/2. And that's where they got that, they just left it. Or you could say 4 to the 1/2 is the square root of the square root of 4, sorry, which is 2. You could also say that. You could also say that, actually. Okay. Alright, so how do you convert between logarithmic form and exponential form? If you have log base b of x equals y, then x equals b to the y. Okay? Alright, so some basic properties of logarithms. Log base b of 1 is 0, because if you rolled this log, you would get b to the 0 equals 1, and that's true because anything to the 0 degree is 1. If you rolled the log, you'd have b equals b to the first, which is true. If you rolled the log here, all right, you get b to the y equals b to the y. This one you can't really roll the log, okay, because it's in the exponent, but here's what they're trying to show you. All right, any log of 1 is going to be 0. Okay, any log of 1 is going to be 0. Any log where you see where these two bases match, then whatever's up here is going to be your answer, because basically these would cancel out. Same here, if it's not a 1, these match, so whatever is up here is your answer. And again, here, if you have a base and a log of the same base, those cancel, and your answer is x. Okay? When you have common log, a common log means that your base is 10. Okay, and they don't write it when the base is 10, but your base is 10. So same thing here. Okay, any log of 1 is 0. These match, so my answer is 1. These match, so my answer is y. These match, so my answer is x. It's pretty simple. Okay, so log base 9 of 9 squared. Again, these cancel because these match, so my answer is 2. These match, so my answer is 3. These match, so my answer is x squared minus 1. These match, so my answer is x plus 2. Done. Okay? Alright, now we're going to evaluate each of the following using those rules. What do you mean, miss, using those rules? I was thinking these were going to match so I could just get the exponent. Well, that's the trick. They don't match, but you need to try and make it match. Since your base is 3, I want to see if there's a perfect amount of 3's in there. If there is, this technique works. If there's not, then this technique doesn't work and you have to wait till I teach you the next technique to solve it. So obviously the ones they're going to give you today are going to work. So break it down by 3's. That would be 81. by 3 would be 27, by 3 would be 9, by 3 would be 3. So would you agree that 3 to the 1, 2, 3, 4, 5, 3 to the 5th is equal to 243? So I can replace this, not the log, not the base. I'm just going to replace 243 with 3 to the 5th. And now they match, so my answer is 5. Okay? Log base 10 of 1,000. Again, these don't match, but if I break 1,000 down by tens, 10 goes into 1,000 100 times. By 10 is 10. So would you agree that I could rewrite 1,000 as 10 cubed, which would give me log base 10 of 10 to the third, because I rewrote this as 10 to the third. Now they match, so my answer is 3. Okay, this one's a little funny. You got the cube root of 64. Well, if I break down 64, by 2 is 32, by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2. I'm looking for cube roots. So there's 3 2's, which makes 1. There's 3 2's, which makes 1. So the cube root of 64 is 4. So this is log base 4 of 4 to the first. They cancel, and my answer is 1. Alright, here, this one, you don't want to break it down necessarily by tens, but would you agree that I could rewrite 0.0001 as 10 to the negative 1, 2, 3, 4, 10 to the negative 4? And if I did 10 to the negative 4th, well, I'd actually do 1 times 10 to the negative 4th, which is 10 to the negative 4th, which is negative 0.001. Okay, because if you went 1, 2, 3, 4, there's your 0.00. 1, 2, 3, 4. Oh, but it's 1. Yeah. So it's 10 to the negative 4th. Anyway, so I'd rewrite this as log base 10 of 10 to the negative 4th. Those cancel, and my answer is negative 4. Okay? We just did this. What did I do? Did I hit the wrong thing? Okay, so if I evaluate these ones, I need to rewrite this using a base of 5. Well, for crying out loud, this is ridiculous. Well, first of all, let me break down 125. By 5 would be 25. By 5 would be 5. So the first thing I'm going to do is rewrite that. So I'm going to have log base 5 of the 7th root of 1 over 5 cubed. Okay? Now I'm going to move it upstairs. So log base 5 of the 7th root of 5 to the negative 3rd. Now I'm going to get out of radical. So that's going to be log base 5 of 5 to the negative 3/7. Because remember, when you do, if you have a to the m over n, it's the nth root of a to the m and backwards. So I started with the square root. This would be the numerator, this would be the denominator. And now these match, so my answer would be negative 3/7. Alright, we just did, oh, this is the 4th root of 64. Okay, so if I break down 64, by 2 is 32, by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2. But now I'm looking for 4. So 1, 2, 3, 4. That would be 1, and then you would have the 4th root of 4. Ooh, that ain't gonna help. Oh, my bad. I want 4s. Sorry, I want to know how many 4s. Well, there's only 3 in 64. What the heck? Oh, I know what we're going to do. Okay. So let's rewrite. So I have log base 4 of 1 over 64 to the 1/4. If I break 64 down by 4s, because I want to use 4s, 64 by 4 would be 116, by 4 would be 4, so it's 4 cubed. So would you agree that I could rewrite 64 as 4 cubed? Okay, so now if I power my power, that's going to be log base 4 of 1 over 4 to the 3/4. when you multiply, you just do the tops. Excuse me. Get this out of the denominator. So I'd have log base 4 of 4 to the negative 3/4. And now they match, so my answer is negative 3/4. Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 1. Alright, first of all, I'm going to rewrite 81 using 9s. So if I break it down by 9s, 81 equals 9 squared. So I have log base 9 of 1 over 9 squared. Move it up. That's going to be log base 9 of 9 to the negative 2. Those cancel, and my answer is negative 2. Alright, hit pause, come back when you're ready. Alright, this I can rewrite as 10 to the negative 2nd, which, and again, you just count the number of places behind, and that's going to be your exponent. And remember, if they don't write a base, it's base 10, which those match and gives me negative 2. Okay, try this one. Come back when you're ready. Hopefully you got negative 1/2. Alright, I need to rewrite 49 using 7s. My 7 is 7. So I have log base 7 of the 4th root of 1 over 7 squared. I'm going to move this up. That's going to be log base 7 of the 4th root of 7 to the negative 2nd. Then I'm going to get out of the radical. So this is going to be log base 7 of 7 to the negative 2/4. Those match. That's my answer, but it reduces to negative 1/2. Okay, alright, when you have the natural log, the properties are the same. Any natural log of 1 is 0. When you take the natural log of e, okay, what the base of a natural log is e. They don't write it, but the base of a natural log is e. So basically, when these match, your answer is the exponent. These match, that's your exponent. These match, that's your, answer, not your exponent. Your exponent becomes your answer. Okay? Same with base 10s. So that's the natural log and the common log I already told you about. These are base 10s. Any log to 1 is 0. When these match, that's your answer. These match, that's your answer. These match, that's your answer. Okay? Alright, so it says evaluate e to the ln of 21. Well, remember, that's base e. Those match, so my answer is 21. This is a base e. Those match, so my answer is x squared minus 1. Evaluate each of these expressions. Again, that's base e. Those cancel. My answer is 7. That's base e. Those cancel. My answer is x plus 6. Simple, simple, simple. Alright, so you try this one, hit pause, come back when you're ready, and hopefully you got negative 9/2. I'm going to get out of the square root, so I have ln, and remember that's base e, 1 over e to the 9/2. I'm going to move this upstairs, which is going to give me ln of e to the negative 9/2. Those cancel, and my answer is negative 9/2. Okay, do this one, hit pause, come back when you're ready. These are so easy. These match, so my answer is 9. Alright, it says find the following using a calculator. Please remember, the only time a calculator works is if you are in base 10. The calculator does not work for any other base than base 10 or your natural log, because you do have a natural log key. Give me just a second to grab the calculator. Alright, so you literally find your log key, which is right next to your 7 key. And so you type in log -7, and it says quit, non-real answer. and that's because you can't log a negative. So this would be no solution. To do this one, your ln key now is right below your log key. So you type in ln, or hit the ln key, and type 0.989 and hit enter, and you get negative 0.01106094474. It says round to 4 decimal places, so 1, 2, 3, 4. Look at the 5th. The 6th is going to bump that up, so my answer is negative 0.0111. Okay? Alright, so you do this one, hit pause, type it in the calculator, and you should get 3. Type this one in, and guess what happens when you try an ln, a negative? It does not exist either. Okay? So how do you evaluate common and natural logarithms? Well, if you're evaluating them and they're common and natural, you use a calculator. Or you can use the properties. Meaning you can convert like this and solve for x. Or you can use any of these properties, and because they match, your answer is just the exponent. Alright, so we are at homework, which means we are done. Happy homeworking, and I will see you next time.